Hey everybody. Again, although I am doing product marketing, I have a pretty long history in doing engineering itself. Actually, before getting in this role, I was doing some evangelism about data engineering stuff with Spark and everything. So I hope I'll be able to bring out some of the business benefits as well as dive minimally on some of the engineering aspects and highlight some of these things so I could talk to multiple levels. But what I wanted to do over here is elevate a little bit the messaging because I feel that bringing data just from the edge is one piece of the puzzle. So I wanted to elevate it and touch a little bit more on the additional pieces that would fit, and hopefully we could have a productive discussion around this afterwards at least. So before I start, this is a life cycle that most companies these days would probably highlight. We cover, IoT. We cover AI at the edge. We go AI, at the very end once you actually collect all that data and bring it in. So you prepare it, you analyze it, right, and then you do all the prediction, and of course how you publish those models and push them down. But of course for this specific session, I really want to focus on the data flow piece, data flow and then stream processing. So in our case, data flow is everything to collect and move data, and then stream processing, I'll mention it briefly, is the next step. So once you actually have the data, how do you analyze it, how you build your data products? So you may have seen this slide if you checked out the IBM booth. I had a few talks with Lynn today. But essentially, the key piece that I want to address is how do you minimize that data latency? So when the business event occurs, how do you bring that data as quickly as possible so then the next steps, the analysis, and then the decision can take place? So one of the key items is, of course, once you've captured the data, how quickly can you bring it in for the rest of the system so then the decision can be made? So the core focus will be on this piece, but of course these are the other items in the later stages that would have to be addressed by other organizations, other verticals in your organization. So what I really want to address is, on the bottom left, these would be your edge devices. These could be your laptops and servers generating all kinds of logs, IoT devices, and of course applications, mobile apps, and everything else. But within these pictures, there are other systems that are generating data that's critical to most businesses today. And especially when you go enterprise, you're looking at multi-cloud environments, hybrid, combining data centers with those clouds and everything in between. What we've noticed is that for all these different systems, for the data movement especially, and collection across these different systems and sources of data, you may need a lot of different point solutions. So the question is, how many solutions does your organization manage? How many of those solutions do you need to effectively move data and bring new data sources online? With some of the customers we've talked, there's at least 5 different point solutions at the enterprise level that they have to manage to move the data around, to switch between different cloud environments, because everybody has their own ways of bringing data into the environment and then moving data elsewhere. In the previous slide, you saw the data lifecycle. So originally, as Cloudera, we've started the same way. We basically thought, how do we enable you to bring the data into your data warehouse? But now, we've looked at it more holistically as, bring data, everybody's doing it. Everybody's got connectors and ways to bring data into your environment. But how do you actually egress the data? Or how do you connect other systems? For example, how do you connect Confluent to Snowflake? How do you make it efficient? How do you move data from AWS to Azure? You may have multiple cloud environments. You may have acquired a startup that's on a different cloud than yours. So we talk a lot about hybrid cloud, but I think what's even more important is having the workload portability. How do you move the workloads from one environment to the other? Or at least how do you connect those workloads so you can effectively act on everything that's going on in your organization? How do you have the 360 view of all the data that's coming in from all those sources? So for us, we have we've looked at how many connectors or processors we have within our product specifically called Cloudera Data Flow. And we have over 450 connectors. And we've seen that with all of these, you can pretty much connect any of these sources and destinations together, which is really cool, which means that you just need one solution versus multiple others, or at least enhance the solutions that are there to make sure that you can move the workloads to other places. And we've decided to call this and refer to it as this universal data distribution. So if you don't go with our product, if you go with another, like the key question should be, how do you manage all the data? How do you ingest it? How you process it? How you deliver where it needs to be? Any kind of data, right? At any rate, real time, batch, micro batch, and all of that. The key is that having fewer tools, and that actually comes from one of the customers we've talked about, can actually cut down drastically on the networking costs. One of the customers told us that by having your solution, we can cut the networking costs by over 50%, just because we don't have to duplicate the movement, which is especially expensive in a cloud environment. And that was, to me, that was very insightful information. So when we refer to universal data distribution, there are three components that are critical. For one, you want to be able to bring the data that is born in the cloud as well as outside the cloud. How do you ingest the data? Do you have active connectors as well as the passive? The active ones would be able to go in and pull the data when needed, while the passive ones would be able to acquire data when it's pushed to them. So for example, financial institutions might not allow you to connect and grab the data from them for multiple reasons, but they may be willing to push the data so then you can then flow it to other destinations. Of course, what you need is, and what's really relevant is how you route it, how you filter. Filtering at the edge. That's a very key component, very important component, because you can pre-filter a lot of the data that's not needed at the edge and only send the critical data that you care about. Again, minimizing the networking costs and moving the data from the source to destination. Minimal enrichment and transformation at that stage may be important, but of course, what's very important at the end is, do you have native connectors to connect to these other solutions? Confluent, Snowflake, Databricks, and so forth, right? So one thing that we're working on is expanding this breadth of connectors so that you can easily move the data where it needs to land. This is, I wanted to do a live demo. Unfortunately, on the new MacBook that I had to upgrade recently, I couldn't install VirtualBox. It started crashing on the M2 chip. But this is part of the solution. The solution underneath of the data flow is Apache NiFi. And this piece is Minify, deploying Minify on these edge agents, and then managing those edge agents in really high quantities. We have a customer that's got over 200,000 edge agents, and we can basically update them whenever we have a new update to push. It's not an active push, but basically there's a timer, there's a countdown when they check in, and then new updates as they're available can be pushed to those edge agents. One of the cooler edge agents that's really relevant for this conference, one of the processors, is actually pushing and having new models. So now, for example, if these edge agents, especially if we have some 100,000 plus, check in every 10 minutes with the central monitoring and say, do you have a new AI model for me? They can grab that model and automatically push it to the edge and have it updated. So having that centralized management is key. Now I'll go pretty quickly over these other slides because I want to go to the live demo very quickly. This is the piece where now you can manage in this low-code, no-code, sort of drag-and-drop environment easily all these processors or connectors depending on what their functionality is. Processors generally if it's just transformation, enrichment, perhaps filtering, and the connectors would be referred if they actually connect to a source and a destination. The big piece that we found talking to developers is how quickly can you bring new sources of data online? How quickly you can connect it to another destination. And we found that these no-code, low-code solutions, as you will see in a few minutes when I do the demo, is very important because you can just drag and drop these pre-built connectors and you can quickly replicate these via templates for similar flows. So then the question is, you've developed this in this stage, how do you actually productize it? So most of the work that we've done until recently was for these always running workloads. So you may have these real-time data requirements, real-time streaming data requirements, so with very strict SLAs, so then you can process data as it's coming in a millisecond type range. So this is great. The thing is that these workloads generally have to run 24/7, right? Even if you have just 2 or 3 nodes, they always have to run in the back, so then when there's a burst of data, they can quickly scale up. So that's one case, the one on top over here for data flow deployments. We've recently released data flow functions, which is optimized for these NiFi flows for the serverless environments. And that can actually, for these specific use cases where you have these ad hoc events, trigger-based events, becomes relevant because now you only run it when you need to process these flows. This could be some batch data that's arriving. These could be some scheduled events. I'll briefly talk about one use case where this has been used effectively. So now you can optimize on the cost in your production environment depending on what type of use case you're addressing. And then, of course, these dashboards where you can quickly analyze, monitor, and manage these flows in the tens or hundreds or thousands, depending on how many of them, also becomes critical. And then I'll show you this, which is a ready flow gallery. This one is pretty neat because you can what we started doing, you can quickly grab a common flow deployment, for example, Confluent Cloud to Snowflake, and within minutes deploy a new connection. So you just customize these templates, and we're basically building them out as we get feedback from customers and developers, like what are these most common flows that they would like to use. So let me quickly jump in a demo over here. All right, so this is the dashboard for Cloudera Data Flow. And this is one of these flows that has been deployed. I already pre-filtered this one. As you can see, there's some throughput that's already running. That's basically data that's coming in. The neat part is that now you can set your KPIs. In this case, not many have been deployed. And of course, all kinds of system metric and alerts. What I want to show you is really this NiFi development environment, if it loads properly. There we go. Let's go to Actions, View NiFi. So that's your low-code, no-code development environment. And basically, all of that is done in this very intuitive, GUI-based layout. And you can very quickly grab a new connector or processor over here and just decide what is it that you want to do. For example, if I type in Kafka, I can quickly get a Kafka consumer. This will be Kafka to CDP. Let me add that over here. And then, assuming it's a correct one, I could connect it to, for example, this one, set schema name. And then you basically add some details and settings and so forth. But we're not going to do that here. Just want to show you how quick and rapid it is to add these different pieces that can make these super powerful flows literally in minutes. And we had this one use case where one of our solution engineers on an actual call was able to develop a flow for a major customer within the actual session, initial engagement by one of our account representatives. So the question should be, how quickly can you develop these flows? How quickly can you bring them online from basically development to production? So once you have something like this flow, it literally takes a few clicks to deploy to production, again, in any type of public cloud, so AWS, Azure, or Google Cloud. So this is one piece. Let me go back here. The thing that I've mentioned already is this ready flow gallery. So again, if you have needs to have these very common flows, for example, Kafka to Kafka with some pre-filtering, S3 to S3 Avro, let's see, there's Azure Hub to ADLS. I mentioned the Confluent Cloud to Snowflake. These are some of these ready flows that are important. So the other question should be, can you rapidly deploy these flows? Can you make them functional for you and basically provide a lot of business value rapidly? So that sort of time to bring out new data sources to have that competitive advantage. And of course, last piece that's pretty neat that we released recently is that function environment. So depending where you want to run them, that event-based trigger sort of ad hoc when the flow needs to be run, very easy way again to deploy these flows. So that's just a quick demo of the product, but hopefully that sort of inspires you to sort of think in different ways of what these different products can do and how you should approach the sort of edge to other pieces of your enterprise movement of data. So this is one of the cooler use cases. This financial services company basically wanted to pull in the data, the financial data from Bloomberg, and then have it available for further analytics. Because pulling the historical data from Bloomberg is actually costly. So what they've decided, when the new data comes in, they would just trigger an event, in this case using that data flow functions for that serverless type of processing, bring in data, shut down the service, and then have that data in their own local data warehouse. And that was a really powerful use case because now they saved a lot of money just by bringing the data in, so that data always lives in that environment. This one, oh yeah, this is another piece. So now you've brought the data in. Of course, the next question should be, what happens afterwards? So with Apache NiFi or other streaming solutions, that's going to be like data in motion, right? It could be high velocity, slow velocity data, but then how do you combine the data with data at rest? Do you have a SQL-based solution to quickly query the data, get rapid insights, or do you have to wait for long development cycles, sometimes weeks or months, to get that new real-time stream online? So that is another piece that should be considered. How do you bring the data in quickly so that data is available for immediate insights? This is another use case I want to talk about. So remember when I referred to the hundreds of thousands of edge devices? This is the actual energy company that has these laptops and PCs that generate all kinds of log data. So one of these concerns, especially in cybersecurity, is you might have these logs that are critical. So for example, in this case, a Windows firewall service has been stopped. Now that was just one computer, but what happens if you have hundreds or hundreds of thousands of these machines all coming in? And how do you process it? One of the things that they had that was really costly is grabbing all those logs and putting them into a SIEM solution. What that means, they're basically putting all these logs, for example, Splunk, and that became costly because they've captured all of this log data into one solution, but not all of that log data was relevant. So now, how do you curate that log data so that you only send the critical data to your SIEM solution, for example, Splunk, and then push all the data to a much cheaper solution, such as a data warehouse? So that could be, Cloudera data warehouse. It could be any of the major data warehouse out there that make it cheap to store this long-term data, but then you can do analytics that are relevant and interesting, that put insights. And in this case, the energy company not only was able to increase their cyber threat detection from 70 minutes to 7 minutes, so a 10x improvement, because they used one solution, brought data in, millisecond response, but they also saved a lot of money on this solution. Over a 5-year period, they looked at of 2 million savings just because they limited the number of networking usage that they had to push all the data in. And of course, collecting data and managing with one platform instead of multiple platforms. So instead of having multiple point solutions, having just one solution, one core management, also lower their overhead costs of admins, development, and so forth. So now all the developers are using the drag and drop. This could be developers that are much more junior because it's much easier to understand it, to bring it up, and you don't need all these massive code templates to develop this. So again, there's a big benefit and different personas involved in these stories and then the use cases that you would address depending on your needs and how you think about these point solutions that need to be integrated into your environment. So basically, this is the highlight of our product portfolio, specifically Cloud Data Flow. But really what I wanted, some of the key takeaways I want to be like, how do you ingest and move data? How do you collect it? Do you have an ecosystem of connectors that you can easily use to collect and push data elsewhere? Do you have runtimes, production runtimes that are optimized for different workloads, different events, ones that are running real time versus ones that are ad hoc, trigger-based? Do you have low-code development tooling? Is it drag and drop, or do you need to have these massive code repositories? What happens when developers leave? Like, do you have that easily handoff to have developers start using this tool? Very importantly for IoT, do you have security and governance built in, right? All of the Cloudera suites got it, but for any tooling, that should be #1 question. Do I have to worry about it? Is it something that I'll have to implement afterwards, or does it come in baked in the solution? And of course, in this case, this solution is integrated in our portfolio of the full data lifecycle. but for any system is, does it easily integrate with your solution? So those should be the questions that everybody should be asking. This is from our perspective of how do you think about this ecosystem, this data ecosystem that has to be interconnected to successfully drive outcomes and increase ROI. With that, I think I've got a couple minutes for Q&A. This QR code will take you to the Cloudera Data Flow page. Little pitch from me from a product marketing side. But if you have questions, I'll be here, or I can answer some of the questions right now in the next 3 minutes. If you have a question, do raise your hand. If not, I'll leave this hanging for a few more minutes, and I'll be right here. Thank you.